Let's try an example with a graph. This problem states the limit as x goes to negative 2 of f of x, which is represented in our graph over here. So the first thing, let's find where x is negative 2. There's x at negative 2. Now I need to see what part of the function or the graph is on the left side of negative 2. That would be this line right there. And we know that a function will continue heading in that direction. So for this problem, we have the limit as x goes to negative 2 from the left. Notice how I added that little negative sign after the 2? That represents that it's coming from the left-hand side of our function. And that guy is headed to negative infinity. But now we have to check that graph coming in from the right-hand side. So as it's approaching negative 2 from the right-hand side, this graph is going this way and headed all the way to positive infinity, which means the limit as x goes to negative 2 from the right, notice the plus sign from the right of our function, is going to positive infinity. If this was you and your friend, if one of you is headed down to Florida and the other one's headed up to Canada, are you going to meet? Nope. So guess what? The limit does not exist. Because from the left is going down, from the right is going up. They can't hug. They can't kiss. A kiss is a closed-in circle. They can't meet. Therefore, that limit does not exist. However, does the value at negative 2 exist? What do you notice at negative 2? What you notice is this dotted line, right, which is an asymptote. And that means there is no value at negative 2. So for this problem, the value also does not exist. Let's look at the same graph, but we're going to look at a different x value. So for this one, we're looking at when x approaches 0. So where's x 0 at? That's where we're looking. We're looking on this line right here. And of course, we have to check from the left-hand side. This is where the graph is coming in from the left-hand side. So when you look at that point, you can say the limit as x goes to 0 from the left of this function. What is our y value? It looks to be a half. But now we also need to check this coming in from the right side. So from the right side as it's approaching x, we're coming up that way. So now we have the limit as x goes to 0 from the right of the function, and that's when your y value is 4. So again, in this problem, if this is you and your friend, one of you is headed to 1/2, the other is headed to 4. Can you hug and kiss from that distance? No, you can't. Therefore, the limit of x at 0 is it does not exist. But what about our value? Values are your closed-in circles, correct? Values are your closed-in circles, which means the value is 4. So as you look at these, you've got the value at 4, and your limit does not exist. Let's try another problem. Same graph, different x value again. The limit as x goes to 2 this time. So let's identify where x is 2. So we know where we're looking. We need to come in from the left-hand side. So now we have the limit as x goes to 2 from the left. Notice I'm using that minus sign from the left of our function is headed towards, again, 1/2. But now we need to check from the right-hand side, where's this graph headed? Here we go. And we'll notice from the right-hand side, if we do the limit as x goes to 2 from the right, notice the plus sign for the right, of our function. And where's that? That is also at 1/2, which means if they match from the left and from the right, then you have a limit. So our limit in this one, as x goes to 2, is 1/2. Do you need to write out these steps from the left and from the right? Nope, not every time if you don't need it, okay? But I'm writing them out so you can see the process. But now let's talk about the value at f of 2. If we're talking about the value at 2, let's go up here to our graph and find out where's the value. I don't see a closed dot, do you? All I see is an open circle. If all you see is an open circle, can this have a value? No, it cannot. So our value does not exist. So again, notice how your limit and your value do not have to match. Let's try one more using this same graph. Now we're doing the limit as x goes to 4. Let's find out where x is 4. Right, now we have to look at the graph coming in from the left-hand side. From the left-hand side, where is that graph headed? Correct, we are going, x goes to 4 from the left of the function. It's headed to positive infinity. Now we got to check the graph coming from the right side. And from the right side, where is that graph headed? Again, from the right, remember, it's that plus sign. And it is going to positive infinity. So they're both headed the same direction. So guess what? Your limit is headed to positive infinity. The reason why I also write the negative and the positive signs for you guys, because sometimes in your book, it will just ask you from the left or from the right. So you need to know what the minus and the plus signs are on the right side of the number. Now let's look at our value at f of 4. Again, values are closed in circles. We have a value. What is our value for f of 4? It is 2. So again, we have another problem where the limit and the value do not match. Let's try some more problems. The limit as x goes to -4. So first, let's find where our x value is -4. Let's identify our function coming in from the left-hand side. Right? Let's identify it coming in from the right-hand side. And are they hugging? Yes, they are. So they're at the same place, which means our limit is our y value at 2. But now let's look at the value at -4. Notice when the y value is 2, that's an open circle, so that is not a value. Our value is going to be at the closed dot. And the closed dot y value is 0. Let's try another x value. This time, our x value is at -2. Okay, I'm just marking where the x value is. We need to check the function from the left and from the right. So as we come in from the left, it's heading down to -infinity. And if we check it from the right, it's also going down to -infinity, which means our value, which means our limit is headed to -infinity. But now what about our value? Remember, values are closed circles. So our value when f is -2 is also -2. So notice our limit and our value, again, are different. Let's try another one. The limit as x goes to 0 of f of x. So first let's find where x is 0. And we have to look at this graph coming in from the left-hand side. As we're looking, as x is approaching 0 from the left, where are we going? We're going to 0. But now we got to check this thing coming in from the right. Coming in from the right, it's going up there. So you can probably tell by looking at it, the limit as x goes to 0 from the right of this function is all the way up at 5. So they're not in the same place. Therefore, our limit does not exist. Now let's look at the value when x is 0. When x is 0, we're looking for that closed-in dot. That closed-in dot is right up there at the top at 5. Let's do one more. The limit as x goes to 4. So first I'm going to find where my x value is 4. I'm going to follow the function in from the left. I'm going to follow the function in from the right. And check that out. They're meeting. And they're meeting at the y value of 0. But now let's look at the value at 4. The value of 4 is also 0 because remember, a line is a bunch of closed dots all smashed together. So in this problem, our limit and our value are the same.